So we are changing the bit. We want to remove this one. This one is a 1/4 inch down cut, and we want to use an 1/8 because it will be useful for what we want to do. So there are these two tools which are very important for you to use. This one is very specific to the machine. This one holds, and this one unwinds that part. So you have to make sure that you hold it like this, and for you to remove it, you have to go anti-clockwise. So you do this one, and okay, anti-clockwise this way. Okay, so you hold, yeah, and if you just do it once, it will become loose. And when it becomes loose, when you just hold this one like that with your hand, yeah, and remove it like this. It's going, come on. This is how it looks like. So you remove, and so this is a 1/4, the one we removed. Okay, you can't read there, but this one is a 1/4 inch diameter. We have removed it from here, and now we're going to use an 1/8. This is an 1/8 of an inch. So you just place it there like that. It doesn't have to go all the way because you need some allowance, roughly halfway, yeah, or a third. So you take this part. You can start with your finger, feel free. Hold it first here, make sure it clips in, then you use your hand a little bit just to make sure that it gets to that point where it's sticking. Yes, when you're at that point, don't use a lot of force, just do it clockwise once, yeah, don't do it too much. So that's how you change your bit. So the next thing we're going to do is now, this is our work area. This is where we're going to do our design. This is the design that is going to come here, and we measured this part, of course, giving an allowance of an inch X and an inch Y. So you have to mount it here. This is the sacrificial board. The purpose of the sacrificial board is just to prevent your bit from screwing the metal part, the aluminum part, or just to help you hold this one in place. So what we will need, we're going to need is screwdrivers. So I'm going to do it very fast. You just do it on the edges. I'm going to pause and I will do so this is the last one. We have this one. So I'll just put it there. I start, of course, you just start slowly. Just hold it slowly, then it will automatically go in like that. And now you have mounted your work area. This is your work area. Always make sure that after using these tools, you just take it out of this space, because if you have it here, this one will come and knock it off while you pray. You have a machine running. So I'll just take it and put it aside. Now I am taking you directly to some of the designs, how we did the design. So there are different softwares you can use. We used this software called Adobe Illustrator, which we were able to jumble the letters, because right now we just want to have these letters printed by themselves so that we can pick them and put them somewhere. So we used this one to edit and make sure that we have the exact measurement of our tool part. You'll note that it's 10 inches by 10 inches, and 10 inches by 10 inches is exactly this distance, 10 by 10. That's where this one will be cut from. Apart from that, we also have another software we used, and the other software is the VCurve Pro software. So with this software now is let's open an existing file so that you see. So with this software now sets the default of what you are doing to respective for this machine. So you will note that here we made sure that we gave it our work area, which is 10 inches by 10 inches. We made sure that this part, the lower left of our boat, is where we want everything to start from. Our thickness, it always starts at 0.5, but here we made our thickness to be 0.37 for the specific one we are working on. And we always make sure that this part is there and just click OK. And after clicking OK, it also has this part for toolpaths. So for the toolpaths, if you want to do a cut is when you want to now remove something to have the drill bit go up to the end. This is where you'll always go to. You'll always click to the profile, and when you click at the profile, it will give you a few settings. It will show you the depth that you want. This will be the cut depth that will go up to the end. So you can add something like 0.03 inches to the original thickness of your material and make sure it starts 0. And here this one we had used on, but right now we want to use outside. For this specific one, we will have to use outside. So we'll just go and pick this one, and here let me just correct this. Here we're going to use 0.405 because that's what we have added. We have added here our thickness. We're going to use a thickness of 0.375. So 0.375, if you add 0.03, it gives you 0.0 it gives you 0.405. so this is what we're going to use. And our width and height, we're just going to maintain it at we're just going to use our work area as 10 by 10. So if everything is okay, this is okay, we're going to use inches. You're not going to scale. Click OK. Toolpaths, 0.45 is okay for us. And here what outside means, as you look at this arrow, we'll be drilling it from this side because we want the letters. So we'll go down, and going down you'll see a part called tabs. Tabs are things that help the letter. For example, this letter, if you cut it up to the end, if you reach at the part, the end part, it will jump out. So if you don't want it to jump out, you have to put things that will be attached to it, that will hold it. Those are called tabs. So we'll just give it, we go to tabs, edit tabs, no vector. We have to select. Sorry for that, we didn't select. So selecting, you have to make sure that you come to the selection tool, and you pick everything here. After picking everything, come here where we want tabs, edit tabs. We need a lot of tabs, like 2 per each. 1 2 3 4 5 6 7 8 9 10 11 12 13. We can say 26, but we are free to add if we want to. So we can just write 26. Constant number, constant distance between tabs, not really. Then you just click add tabs. It has added per individual. So actually it has done 26 per individual. So let's go with 3. 3 is a safe number. So just do 3 and add tabs. So 3 is always a safe number. So after doing that, we are having our tabs. We are ready to go. So we'll come and save this profile. So we can save this profile as, maybe let's call it profile 3, and this one we can just call it letters. letters. Profile 3 letters. Then after doing this, we want to calculate so that we see how our thing will look like. Oh, another thing we've not done. Oh yeah, we are using 1.8 ball nose, a quarter, yeah, an eighth. That's not a problem. That's exactly what we are using. So and how we selected that, you only select from here. Just yeah, because we are using an eighth, you just come and pick it directly, so there's no any issue with that. So you come here, we have named this part, so you just calculate, it will bring this. So make sure you just read it. The material thickness is 0.375, but the maximum tool depth where we want it to cut is 0.405. That's okay. So you click okay. So it has shown us what it's going to do. So if you want to preview exactly the job, you come here and click at preview visible toolpaths. So you'll click at preview. So and this is exactly what it's going to do. You know that there are these small things. These are the tabs we made. So these are the actual letters we want, and we will take them out and put them somewhere else. So we have something which is very cool. After you've made sure that you can move it around, look at it from the other side, you see it's cutting up to the end. This is exactly what we want. So after making sure that you have exactly what you want, go back to the toolpath. Then we now want to of course we want to save everything, but now that we've seen everything, we can just come at close. After closing, this is the save toolpath. So you just click at here, save toolpath, and you'll make sure that output all visible toolpaths in one file. That one is checked, and after making sure that is checked, also make sure that the profile 3 letters is also checked. So after doing all that, don't click at anywhere else, just click save toolpath to file. So just click there, it will take you here. You want to save to, but you don't want to save it there, we'll save it at documents. So you know that initially we already had toolpath 1, profile 1. So instead of calling this profile 3, I just call it profile 2. Call it profile 2, then click save, and we have our design saved, ready for the machine, the Shockport. Now the next step we want now to connect the Shockport desktop to the software that runs the Shockport 3 software. So before running the Shockport 3 software, make sure that your Shockport desktop is on. So how do you make sure that it's on? By putting it on, and after putting it on, you also make sure that the control box is turned on using this key. And you'll note that it's writing 131 F, the frequency to be 131, and that's the last frequency we used, the speed we used. So after that it's on, so we are heading directly to our the software we use that controls the machine itself, the Shockport. It's called the Shockport 3 software. So you just right click. After right clicking, you run as an administrator, and this will come. You just click yes. After clicking yes, it will give you time. All this will come. Then when this comes, then we are now ready to set the X and Y axis, because we can just make sure that the machine is running by using this control button, the yellow one, and playing around with this. So if I press the arrow keys on my keyboard, or I use this one up and down for the spindle, I can use page up or page down. So I want to do this, and I want you to look at the spindle while I'm pressing the left. So right now I'm pressing the left. I'm also pressing the left. Now I'm pressing the right. That's the right. Okay, now we're going to center the spindle. We're going to center the spindle. Centering the spindle, we're going to take it to the bottom left of our work area. We are centering, and you have to make sure that the spindle is closer for you to be able to get an accurate or a close feeling of your board. Yeah, now we are at our starting point, and that's where we want to set our x and y axis. So setting our x and y axis, now that we have picked the bottom left part of our board we want, we'll just come to, we are zeroing, not really setting. We will remove that. I come to 0, and I pick this one because right now we just want to do the 2 axis x and y, and click on it. After clicking on it, you'll note that x and y are now 0, but z has a value 0.227. So we will use this to 0 the z axis. So we are heading right direct to the machine itself, and the machine, what you'll do first is to make sure that the zeroing metal is right under. Make sure it's under your, yeah, it's under your spindle, and you have to use this and hold on the threads of your spindle there. So after doing that, those 2 steps, you now come directly to here, and you click on it. After clicking on it, this window will come. Hit enter when above the plate and ready to go. You first confirm if you are above the plate and ready to go. If you are above the plate, ready to go, and everything is set, okay, hit the metal that way, then it will give you this message: 0, remember to remove the alligator clip and put away the plate. You click OK, and you will go ahead and remove the alligator clip and just secure them. Now the next thing we are doing is the warming up routine, and the warming up routine is very specific to and very important for the spindle. The spindle needs to be warmed up so that it can work perfectly on your material. So because you're going to work on a temperature of on a frequency of 130 as it is right now, we will start by running it from 100, frequency of 100. We'll start from 100, run 3 minutes while the spindle is running. We go to 120, then from 120 we also give it another 3 minutes, 2 to 3 minutes, then we go to 150. Then after going to 150, then we just let it stop. It will take approximate 9 minutes. Then after it's stopping, we will get it to 130, and that's when we will start. So the first thing we have to save the command console. For the spindle to run, you just type C5. It will ask you that way. Right now the spindle is not running. You can show spindle is it's not running. So when I click OK, the spindle will now run, and it's running. It's now running very fast, you can see, and it's running at a frequency of 100.